Hello class, today we're taking a look at solving our simple single-step linear inequalities. So we want to remember that when we're solving an inequality, we use the same steps as we would use for solving an equation. So when we look at our inequality, x plus 5 is greater than 8, we want to ask ourselves, how do we isolate our x? AKA, how do we undo what's being done to x? X is right now being added to by 5, so what's the opposite of adding 5? It's subtracting 5 from both sides. On the left side of the inequality, we just have the variable x. Our inequality sign stays the same, and 8 take away 5 is 3. So our algebraic solution is just that x is a greater number than 3. To put that on our number line, we're going to go ahead and identify that our 3 is our cutoff point. So we're going to put our open circle at 3. It's open circle because we don't have the equals part of our inequality. We don't have that extra line for greater than or equal to. It's just strictly greater than. Now, where are the numbers that are greater than 3? Those numbers are towards the right on the number line. So we're going to make our arrow go towards the right on the number line. And these are all of our possible values for x that would make the equation true, the inequality true. So let's pick some points in our arrow to check in the original inequality. So I'm going to start by picking point x is 4. If x is 4, my inequality becomes 4 plus 5 being greater than 8. 4 plus 5 is 9. 9 is greater than 8, so that point did work in the original inequality. Remember, I can choose any point I want in this arrow. So let's say I choose x is 8. Then my original inequality becomes 8 plus 5 is greater than 8. 8 plus 5 is 13, which is in fact greater than 8. So that point also worked in the original inequality. And again, our idea here is to find all the possible numbers for x that we could put into this inequality to make it a true statement. In question 2, we have 8 times x is less than or equal to 24. So the opposite of multiplying by 8 is dividing by 8 on both sides. Okay, 8 divided by 8 gives us 1x, or just x, being less than or equal to 24 divided by 8 is 3. So again, on this one, we still have our cutoff point at 3. However, this time, since we do have that equality, okay, we do have less than or equal to 3, we're going to shade in our dot at 3. And here we want our arrow to go to the left of 3. It's all the numbers that are left of 3 on our number line. So again, in terms of checking this, we can choose any points that are within that arrow region. So I'm going to start by choosing 0. You could, of course, choose any point. So my inequality would be 8 times my x of 0. Should be less than 24. 0 is less than 24, so that is a true statement. I'll choose any point within this region. So I could even choose something like 1.5 if I want. And if I have 8 times 1.5, is that less than 24? 8 times 1.5 is 12, and 12 is in fact less than 24, so that point works as well. In my next one, x was being subtracted by 2. The opposite of subtracting 2 is adding 2 to both sides. So we'll go ahead and get our inequality that x is greater than or equal to negative 6. Obviously, pay attention to your integers. Negative 8 getting less negative by 2 is negative 6. So let's go ahead and start our inequality at our negative 6. Since we do have our equality part of this, we're going to say that we can be equal to negative 6 by shading in that dot. And then where are the numbers that are greater than negative 6? That's our arrow going to the right. And so all of these would be valid solutions for our inequality. Let's pick a couple of those to verify. I like to pick 0. So I'm going to go ahead and put in that 0. Subtract 2 should be greater than or equal to negative 8. So 0 subtract 2 is negative 2. And negative 2 is in fact greater than negative 8. And so that's a true statement. You could also choose a number like 10. Though I haven't drawn my arrow all the way over there, my arrow does continue, so I know that 10 is also a valid solution. Should be. So let's check it. 10 subtract 2 should be greater than or equal to negative 8. 10 subtract 2 is 8, which is positive 8, obviously. That is, in fact, greater than or equal to negative 8. So that point also worked in my inequality. Okay, next one up, I have x over 2 is less than negative 3. So I want to go ahead and think about what is that over 2 doing to my x? Well, x is right now being divided by 2. So I want to go ahead and multiply both sides by 2 to undo that. That's going to go ahead and give me just x on the left side, and my negative 3 times 2 is negative 6. So let's go ahead and put our negative 6 on our number line. That is right here. We do not have the equality, part of our inequality, so we're not going to shade in that circle. And where are the numbers that are less than negative 6? They're going to go this way. So of course, our arrow is going to go towards the left to be less than that negative 6. And these are the numbers that should be valid solutions. So let's choose some of those. I'm going to choose my negative 8 and my negative 10 for my verifications. I should have that negative 8 over 2 should be less than negative 3. Negative 8 over 2 is negative 4. Is negative 4 less than negative 3? Yes, it is. And if I put in negative 10 over 2, that should be less than negative 3. Negative 10 over 2 is negative 5, which is, in fact, less than negative 3. So I want to talk about this one in particular with comparison to number 5. So let's do number 5. Number 5, we have the inequality negative 2x is greater than 4. So to isolate that x, I need to undo the multiplication of it by that negative 2. So the opposite of of multiplying by negative 2 is dividing. And we'll divide both sides by that negative. So we're going to go ahead and get just x on the left side. And 4 divided by negative 2 is negative 2 on the right side. However, if we are dividing by a negative number, we talked about how this has a special situation. This is going to require us to flip our inequality sign. So we want to make sure that when our operation involves a negative number, that's when we need to flip our inequality sign to make a true statement. Now in question 4, our operation was not involving a negative number. The operation we did was to multiply by 2. So we're multiplying by a positive number there. There's no big deal. Yes, it was negative 3 to begin with, but we were doing the operation to multiply by positive 2, so there's no problem. Here, our operation itself, our dividing by negative 2, involves that negative number. This is where we need to flip our inequality sign. So let's draw that and check that we did get that right. We want x to be less than negative 2 on our number line. So open circle for strictly less than. And then our arrow should go left for the numbers that are less than negative 2. So let's check some of those points. If we check the point at x is negative 4, we should have negative 2 times our negative 4 is greater than 4. Negative 2 times negative 4 is positive 8, which is greater than 4. So that does work in our inequality. We could also check a point like negative 6, and we could say that negative 2 times that x of negative 6 should be greater than 4. Negative 2 times negative 6 is negative 12, and that would be greater than 4. Positive 12, obviously, and that would be greater than 4. So both those points do work. We know that our arrow is going the right way. Another way of thinking about this number 5 is to think about if we rearranged the terms. So just like in an equation, we could add 2x to both sides, and that would give us 0 is greater than 4 plus 2x. We then subtract 4 from both sides, and we get negative 4 is greater than 2x. And so negative 2 is greater than x, which means x has to be less than negative 2. So that would be the other way of thinking about why it should be x is less than negative 2 instead of greater than it. Okay. On the back, we have the same type of thing. It's just we have some different types of numbers mixed in there. So in question 6, we've got negative 5 is less than x subtract 1/2. So what's the opposite of subtracting 1/2? Adding 1/2. I'm going to choose to write that as 0.5 for that 1/2. And negative 5 plus my 0.5 is negative 4.5, which will be less than x. Now remember, you can always start on your x side and read your inequality that way. So if we read from our x, we're going to say that x is greater than our smaller side, which is negative 4.5. So we want our x to be greater than negative 4.5. So let's start by drawing that. Where would negative 4.5 be? Well, it's going to be halfway between negative 4 and negative 5. Let's put our open circle there since we're strictly greater, and we want the x to be bigger than that negative 4.5, so our arrow is going to go to the right. Now again, we can choose pretty much any point within this arrow. So an easy one is usually 0. So if I go ahead and say that negative 5 is less than 0 minus 1/2, sorry, 0 minus 1/2, then I can say that negative 5 is less than negative 1/2, and that is in fact true. And keep in mind, I could choose really any point here. So I could go ahead and choose maybe 1/4 or 0.25. And I could say that my negative 5, my original inequality, is less than 0.25 minus 1/2. Oops, 1/2. And this would mean that negative 5 is less than negative 0.25, which again is a true statement. Obviously, the specific point that you choose to verify doesn't really matter. So if you didn't choose 1/4, I understand. That's all good, but just to show you that it does in fact work. Okay, next one here. We have our 1.5x is less than or equal to negative 9. So the opposite of multiplying x by 1.5 is to divide by 1.5 on both sides. Now to do that division, I think I'm actually going to write that as a fraction. So I'd say 3 over 2x is less than negative 9. Now I'm going to divide by that 3 over 2 and divide by that 3 over 2. That means x will be less than negative 9 times 2 over 3, multiplying by the reciprocal. That would be negative 18 over 3, which is negative 6. Now you could go ahead and, I guess I have that in black, long divide there as well. That would be another option for getting your answer of negative 6. Okay, so let's go ahead and put our closed dot at negative 6, since we are allowed to be equal to negative 6. And we want x to be less than that, so we're going to be going left from that negative 6. And these are all our solutions here. So again, check 2 points in here. So I'm going to check negative 7 and negative 10. Let's do negative 8. It's a little bit easier to do our calculations with. So our verification says that 1.5 times whatever x is should be less than or equal to negative 9. So 1.5 times negative 10 is going to be negative 15. That is in fact less than or equal to negative 9, so that's true. If I substitute in my other point of negative 8, 1.5 times negative 8 should be less than or equal to negative 9. 1.5 times negative 8 is negative 12, and that is in fact less than or equal to negative 9. In the case of question 8, we've got 8 is greater than 2/3 of x. The opposite of multiplying x by 2/3 is dividing by 2/3, so we'll do that to both sides. 8 divided by 2/3 is really 8 times 3 over 2, which is 24 over 2, which is 12. So we can say 12 is greater than x. So this one here goes off your screen a little bit, or off your number line a little bit. And of course our x would be values that are greater than 12. Probably take a look at fixing that question for a future version. Okay, now we should have our open circle there at 12, since we are strictly greater than 12. Even though we're off the page, we could predict what numbers are greater than 12. So let's try the number x is, I don't know, what's greater than 12? Let's try 14. Let's even do 15 to make this calculation a bit easier. And let's say 8 is greater than 2/3 of 15. 15 divided by 3 is 5, times 2 is 10. Oops, what do we have going wrong here? Oh, I'm so sorry. The whole question is just a schmozzle. And that's why we verify. We see if our answer is right or wrong. Our x on this side, is smaller than my 12. So it should be starting at 12 and going back to the left. So that would be better if we could have that. That's by 12, and our arrow should be going this way. Whoops, daisies. That makes more sense now. Good example of, hey, if you verify and something goes wrong, tells you might have made a mistake earlier on, which we all do. Okay, so let's verify some easier points here. Let's do 10, let's do 0, and let's go ahead and do that. So I'm going to go ahead and say that 8 should be greater than 2/3 of 10. 2 times 10 is 20, divided by 3 is going to be, well, a decimal. Okay, I know 18 divided by 3 is 6 and 2/3. 8 is definitely bigger than 6 and 2/3, so that's good. If we put in 0, then we're going to have 8 is greater than 2/3 of 0. So 8 is greater than 0, and that is true. All right, let's finish up these last couple. We're going to go ahead and subtract this 4.2 from both sides to undo the addition. And we're going to get the inequality solution that x is greater than or equal to 9 take away 4 would be 5. Take another 0.2 is 4.8. So let's find out where 4.8 would be. It's going to be somewhere here on our number line. 1, 2, 3, 4, 5. So 0.8 would be here. We can be equal to 0.8. So we'll go ahead and put our shaded circle at that 0.8. And reading from the x side, we want that to be bigger than that 4.8. So our arrow is going to go to the right. Let's verify some points in there. So point at 5 should work, as well as 10. So we're going to say that 9 should be less than or equal to 4.2 plus 5. 4.2 plus 5 is 9.2, so that is correct. And obviously, if we put in our 10, 4.2 plus 10 is going to be 14.2, and 9 is, in fact, less than or equal to that. Okay, to finish up here, we want to go ahead and divide both sides by our negative 2/3. Remember, anytime we divide by a negative number, we're going to need to flip that inequality. 4 divided by negative 2/3 is really 4 times 3 over 2. 4 divided by 2 is 2, times negative 3 is negative 6. So that should be, flipping our inequality, less than x. We read our inequality starting with the x should be greater than that negative 6. So we're going to start at negative 6, not including it, and go to the right since we're greater than that negative 6. Okay, so putting in some test points, we can put in x is 0, and, well, really any x's we want. I'm going to choose x is 6 as well. And let's go ahead and solve that out. So we're going to go ahead and check that 4 is greater than negative 2/3 of 0. 0 times anything is 0, and 4 is, in fact, greater than 0. We're also going to check that our x is 6 works out. So we're going to go ahead and put in our x is 6 into our original inequality. That means 4 should be greater than negative 2 times 6 over 3. Negative 2 times 6 is negative 12. Divided by 3 is negative 4. And 4 is, in fact, greater than negative 4. So I hope that's helped you with your single-step inequalities.